Hello everyone. Today we are going to derive a formula for the shape factor of a I section. Let us consider an I section of breadth B and depth D. Let us assume the depth of flange is equal to small d. Also, the distance from the side of the web to the end of the flange is equal to B by 2. We know the formula for the shape factor S is equal to ZP by Z. In this formula, Zp is the plastic modulus, Z is the elastic modulus. First, let us find Z, the elastic modulus. The formula is I by Y. In this I section, we can easily calculate the moment of inertia. For that, we have to assume that it is a rectangle. We know that in the rectangle, the moment of inertia formula is BdQ by 12. Here, breadth is B and depth is D. Then we are having two empty spaces on both the sides. These spaces are also rectangle. We have to subtract the moment of inertia of these two rectangles by BD cube by 12. For one rectangle, the moment of inertia is B by 2 into D cube by 12. But we are having two rectangles, so we are multiplying with 2. We can eliminate this 2 and this 2. Finally, the moment of inertia is equal to caps BD cube minus small bd cube by 12. Now let us find why. This I section is symmetrical, so the neutral axis lies in the center. The distance between the neutral axis to the fiber is d by 2. So y is equal to d by 2. In the elastic modulus formula, we can apply the values of moment of inertia and y. Then we can take d by 2 inversely and then multiply. We can cut 2 and 12. Here it will be 6. Finally, we are getting z is equal to caps bd cube minus small bd cube by 6 caps d. Now let us find the plastic modulus Zp. The formula is a by 2 into y1 bar plus y2 bar. For calculating the area, let us assume that it is a rectangle. In the rectangle, area formula is B into D. Then we are having two empty rectangles. The area for one rectangle is B by 2 into D. But we are having two empty rectangles. So 2 into B by 2 into D. But this is for the empty area. So we have to subtract it from the total area. We can eliminate 2. In this way, we can calculate the area, which is equal to caps BD minus small bd. To calculate y1 bar and y2 bar, we have to split the I section about the equal area axis into two equal parts. This I section is symmetrical, so the equal area axis lies on the center, same like neutral axis. About the equal area axis, we have to split the I section into two equal area parts. We have to calculate y1 bar and y2 bar from the equal area axis. These two parts are having the same shape, so y1 bar will be equal to y2 bar. Now let us find y1 bar. Here we are having two parts, the web and the flange. The thickness of the web will be b minus 2 into small b by 2. We can cut this 2 and 2. Finally, we will get caps b minus small b. The thickness of the flange will be caps d by 2 minus small d by 2. Since we are having two parts, the web and the flange, the formula for y1 bar is equal to a1 y1 plus a2 y2 by a1 plus a2. This is our first part. In this part, we have to find the centroid. Since it is a rectangle, the centroid will be in the center. The distance between the centroid and the equal area axis will be d by 2 into 1 by 2. Finally, we are getting d by 4. Now let us calculate A1. The area will be d by 2 into caps B minus small b. Finally, the area A1 is equal to half into BD minus BD. Now we can calculate A1 Y1. We have to multiply A1 and Y1. After multiplying, we are getting this value. Now let us calculate Y2. We have to calculate Y2 from the flange. The flange is the rectangle, so the centroid lies in the center. To get the center, we have to multiply this value with 1 by 2. Now we have to calculate Y2, the distance between the centroid to the equal area axis. This distance we have already calculated. This distance is d by 2. So we have to add d by 2. We can multiply this 1 by 2 with these two values. Finally, we are getting this. D by 2 minus d by 4. We will get d by 4. Finally, for y2, we are getting this value. Now, let us calculate a2. This is a rectangle. So, the area will be b into this value. Finally, for area, we are getting this. Now, we can calculate a2, y2. We have to multiply a2 and y2. Here we can cut these two values. Finally, for a2, y2, we are getting this. We have found a1, y1 and a2, y2. Now we can calculate a1, y1 plus a2, y2. 1 by 8 is common, we can take it outside. Then we can cut these two values. Finally, we are getting this. Also, we can calculate a1 plus a2. Here we can take 1 by 2 outside. Here we can cut these two values. For a1 plus a2 we are getting this. In the y1 bar formula we can apply a1 y1 plus a2 y2. We already got. Also we can apply a1 plus a2. Then we can cut this 2 and 8. Here it will be 4. Finally for y1 bar we are getting this value. Now we can easily calculate ZP. We already know the area value. The values of y1 bar and y2 bar just before we found. We can apply all of them. Both of these values are same. So we can multiply any one of them with 2. Here we can eliminate these two values. Also we can eliminate this 2 and this 2. Finally for ZP we are getting caps BD square minus small bd square by 4. Now we can easily find the shape factor. We have already found the values of set P and set. We can apply in the formula. We can take this value inversely and then multiply 6d by 4. We will get 1.5d. Finally, we have found the shape factor for a symmetrical I section. The formula is 1.5 caps d into caps bd square minus small bd square divided by caps bd cube minus small bd cube. Now we are going to end this session. Thank you for watching this video.